What's up geeks, and welcome to the channel. UML, or Unified Modeling Language, is our topic for today, and contrary to many beliefs, it isn't a programming language, but it's a graphical notation used to draw diagrams of an object-oriented system. This modeling language describes and defines several diagrams, but in this video we will be covering two of them, object diagrams and class diagrams, as they represent the building blocks of any object-oriented solution. Now, while trying to cover the basics of class diagrams, we will also be discussing the difference between association, aggregation, and composition, as I figured they somehow really fit within this video, so bear with me. Okay, to start off, a class diagram is a very simple graphical representation of the classes in our system and the relationships they share. Each class representation has three sections: the name of the class at the top, the attributes in the middle, and the behaviors or methods at the bottom. The different relationships between classes are shown by different types of arrows, which we will discuss in a bit. Next to the attributes and methods, we can add the plus sign to indicate that this field is public. The minus sign indicates that it's private, and the number sign or hash indicates that it's protected. The type of our attributes and the arguments passed to and returned by a method can be specified, as we can see in the example. Inside a set of parentheses next to the method name, we can specify the type of the arguments of our method. And after a colon, we can specify the type of the variables returned by this method, along with some default values. Now, let's take our famous bank account class as an example. Fill in its attributes and methods, and suppose that you have two other classes, like types of bank accounts, the savings account class and the miles account class. Both of them are bank accounts, therefore they share an is-a relationship with the bank account class. But on top of the attributes present in the bank account class, the account ID, the balance, and the account owner's name, the savings account has an interest rate attribute, and the miles account class has a rewards attribute and a bunch of methods. The relationship between these classes is obviously inheritance, and it is specified in a class diagram using the arrow we see. Now, let's add to our application a customer class with a name and an ID. Every customer is eligible to have multiple bank accounts, because why not? So, let's add to our customer class attributes a list of bank accounts. And because we are a bank and we want to rip our customers of their money, let's add an additional feature they didn't ask for and let them pay for it. Let's allow our customers to create several sub-accounts within an existing bank account. You see, these sub-accounts are not bank accounts like the savings or the miles one, they exist within the bank account class. The customer has to have an account before being able to create a sub-account. Let's lay out the relationships between our classes. A customer can have multiple bank accounts, but a specific bank account can only belong to one customer. The same applies to the sub-account class. A specific sub-account can only belong to one bank account, but any given bank account can have multiple sub-accounts. This is referred to as a one-to-many relationship. We should also be aware of the many-to-many or the one-to-one relationships. These define an association between our objects. And in a UML diagram, an association is represented with the arrow we just made use of. However, in our case, the customer class is kind of a container for the bank account class, which is called the contained in this case. And the bank account class is also a container, but for the sub-account class, which in this case is the contained. This is referred to as a has-a relationship or a directional association, also known as an aggregation, which is what we have in both cases. We can say that the customer has a or several bank accounts, or the bank account has a or several sub-accounts. So, let's replace these association arrows with aggregation arrows in our class diagrams and take a look at something I hinted at a few minutes ago. If we delete our customer class, the bank account class can still be used by our system. It will in some way still be useful. In this video, we even created it before we created the customer class. But what about the sub-account class? Can we say the same about it? Can the sub-account class exist without the bank account class? If we delete all bank account objects from our application, the customer class will still be meaningful. But what are we going to do with the sub-account class? Well, nothing. It is useless now. And when the contained object cannot exist without its container, this is called a restricted aggregation or a composition, and that is exactly what we have in this case. So we can only update the arrow linking the bank account class to the sub-account class to a composition arrow. However, the one linking the customer and bank account classes has to be left as an aggregation. Now, you may be asking the question, when do we have an association? We will always end up with either an aggregation or a composition, right? Well, let's create a bank event class with the title and the date. The title will be the event the bank is hosting. It could be a branch opening or anything else, and the date would be the date of the event. Let's also add a method in the customer class called subscribe, where a person can subscribe to a particular given event. Now, this is obviously a many-to-many association because many customers can subscribe to as many events as they want or no events at all, and any single event can be watched by many customers or no customers at all. However, this is clearly not an aggregation because we do not have the concept of container and contained, as a customer is not dependent on an event and vice versa. When a customer subscribes to an event, for example, it just takes the date of the event and adds it to their Google Calendar. That's it. We can also see that neither the customer class contains a bank event among its attributes, nor the bank event class contains a customer among its attributes. So the has a relationship is non-existent, and hence we only have an association here. To summarize the differentiation between association, aggregation, and composition, you can think of these relationships either at class level or object level. What do I mean by this? Well, concerning composition, the whole sub-account class cannot exist without the bank account class. We have no use for it. For aggregation, both classes can exist independently from one another. However, a specific bank account instance or object is tied to a specific customer. Without that customer in particular, that bank account object cannot exist, but the customer object can. For association, both classes and their corresponding objects can exist independently from one another, even if a customer does not attend any event, or if an event is not attended by any customer, both classes and their objects can exist in our application. Okay, now that our class diagram is complete, we will briefly go over the object diagram as it is very similar to the class diagram. You see, instead of representing classes, we represent objects, which means that we have actual real-world examples and values. These objects show what a system will look like. They represent the state of our application at a given time. Take this object created using the bank account class. That is how an object is represented in an object diagram. In the first section, we write the object's name as it appears in our application, and the attributes are represented by their actual values at a certain point in time while our application is running. Now, let's take this further and try to derive some more objects from our previous classes to complete our object diagram. And here it is, a complete representation of our previous class diagram modeled as an object diagram. As you can see, the relationship arrows previously used in the class diagram are kept exactly the same when deriving the corresponding object diagram. Let us know in the comments below if you'd like more videos about this topic. And that's it for this video. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.